And today we're going to talk about the volume and surface area of spheres. Volume and surface area of spheres. So there's a couple definitions I want you to write down. So, sphere. Is a locus of points in space that are a fixed distance are a fixed distance from the center. Okay, a hemisphere is half of a sphere. And the great circle. Divides the sphere into two hemispheres. So a sphere is like a ball, right? And this great circle is what I think of as the circumference. Okay? If you took this sphere, and this is two-dimensional, and you cut it in half, this great circle would be the circumference of half of that thing, right? Does that make sense? Does that make sense?
Yes, sir.
Can you picture it? If you had a basketball, okay, and you cut it in half, you could take the flat portion of it and set it on a table, right? Well, the circumference of that circle that the basketball forms is this right here. It's this great circle. Okay? So the diameter of that great circle, what else would that represent? Wouldn't that represent the radius of the sphere? Can you picture that? Can you picture this? You take a sphere. This would be a hemisphere, right? A half of a sphere. And the base of this thing, or the bottom of it, would be the great circle. There's your great circle. So this dimension that dimension right there would be the diameter of the great circle, wouldn't it? See it? And what would this dimension be right here? That would be the radius of the great circle. And wouldn't the radius of that great circle be the radius of the entire sphere? Can you picture this point right here as the center of the sphere, right? Mm-hmm. So if this is the radius, isn't that the distance to everywhere in this sphere? All of these are going to be the same, aren't they? Yeah. It's just hard to draw in 2 dimensions. Got it? Yeah. All right, so let's get some formulas written down. And we're going to go with volume of a sphere. And the volume of a sphere is equal to 4/3 times pi, and now it's r cubed. 4/3 times pi r cubed. Volume of a hemisphere. Isn't that just going to be half of the volume of the sphere? Because a hemisphere is half a sphere. So if you take 4/3 and multiply it by 1/2, what do you get? Do it in your calculator right now. Should have already been done. 2/3. So the formula would be 2/3 times pi r cubed. Right? Or couldn't it be 4/3 times pi r cubed divided by 2? Yeah. Same thing. Whatever you're more comfortable with. And then surface area. Of a sphere. And that's equal to 4 pi r squared. 4 times pi times r squared. So, you recognize this formula, the pi r squared? Where does that come from? Area of a circle, isn't it? So think about it for a minute. If the surface area of a sphere, okay, surface area of a sphere, that's like you're going to take a basketball and you're going to cover it with wrapping paper. You're going to make it fit exactly perfect. Or you're going to take the basketball, the rubber bladder, and you're going to cover it in leather. Doesn't the surface area tell you how much leather you're going to need? Right? Well, isn't that amount 4 times the size of the area of this great circle? Picture it. Make any sense to you? Yeah.
I'm trying to get so the great circle is the half part.
Exactly. If you took page 767 up there on the top, find each measurement, give your answer in terms of pi. The diameter of a sphere with volume 972 pi. So they're giving you the volume. Isn't the volume equal to 4/3 pi r cubed? You got to go backwards to get the radius, right? And then once you have the radius, how can you find the diameter? Double it. So if the volume is equal to 4/3 pi r cubed, and the volume is also equal to 972 pi, don't you take 4/3 pi r cubed and make it equal to 972 pi? What do you do with the pies?
You cancel them out.
You kill them. Now, do you see this 4/3? You can divide both sides by 4/3. And divide by 4/3. So you get r cubed equals, this is interesting, 972
I got 729.
divided by 4/3. And I got 729. Okay, so now, how do you get r by itself? Good call, Ava. You cube root it.
Oh, not square.
Look, this symbol right here. How do you say it?
Square root.
Square root, because there is a 2 here that is implied. It's not written. This is called cube root. That button is one below the off, and it's in green on the black calculators. It's the 3rd root, or cube root. So look, you take, if r to the 3rd power equals 729, you cube root each side. The 3rd root of r to the 3rd is r. And in your calculator, you've already got the 729 in the black calculator. Let's see if you can push second, that button, 3, equals. And you get 9. So the diameter is equal to 18. Does everybody see where that button is? It's right below the off.
So on this calculator, what would you do?
On that calculator, I'll show you once I give you your assignment. It's actually easier.
I got it.
Example C on that page. Volume. They ask you to find the volume. Volume of a hemisphere. And here's your picture. Volume of a hemisphere, that was 2/3 times pi times r to the 3rd. So 4 to the 3rd. So do your answer in terms of pi first. So you can do 4 raised to the 3rd power is, this would be 2/3 times pi times 64. So 64 times 2/3. So 42 and 2/3 pi. And as a decimal, you could push times pi button equals 134. Questions? Yes.
For the unit, would you put meters cubed?
In this case, if that dimension was in meters, then this would be cubic meters. Yes, sir. Volumes in cubic units, areas in square units. All right, so here's some practice for you to do today. Go with page 770. Two through 4. Six through 8. 11 and 12. Take a look at 11 while we're here. On page 770. That's a composite figure, isn't it? Isn't that going to be the volume of the cylinder in the middle? Then it's got two hemispheres on the ends, doesn't it? What do those two hemispheres make up? One sphere. Okay? So it's going to be the volume of the cylinder plus the volume of one sphere. Alright? And then look at the figure to the right of that. What do you see there? Cylinder minus what? What's missing out of the middle?
That's missing?
Yeah, see how it's dashed?
Oh, okay.
They don't do a very good job with the highlighting, but that part's not there. Alright? That's like a cylinder. It's not like a cylinder. That is a cylinder with a hemisphere missing out of the middle. So it's the volume of the volume of the cylinder minus volume of that small hemisphere. Okay?